Some of you know, and it's no big secret, that I was a big fan of the old school CS61A, which at Berkeley used to be taught using Abelson and Sussman's Structure and Interpretation of Computer Programs, which I humbly think is the greatest CS programming textbook ever written. I aspire to write like that. But a very nice feature that I remember from Scheme, or from Lisp, if you've seen that language, is you can do things like maps and filters, which take a procedure that has no name, right, a lambda expression, and applies that expression in turn, for example, to every element of a list. And in fact, Ruby has a very similar syntax using do and end. You've already seen a lot of examples of this. And now it's time to tell you that this is really what it is. What you're doing when you say do end and you've got this vertical bar notation is you're exactly creating an anonymous procedure and you are passing it as an argument to map. Right? So in this sense, you can think of map as, in the Ruby sense, as map is a method that you call in a collection, and the argument that you pass to it is a procedure saying what to do to every element of that collection. Okay, so kind of, and those of you who haven't taken 61A, I pity you, but this version of it was so beautiful. So the syntax is a little bit different, but the idea is the same. Now we're going to extend the idea and use it in a way that actually you probably didn't see in 61A. And we can think of it as turning iterators inside out. So if you come from the Java world or the C# world or many other worlds, which are really all about the same as the Java world, the idiom there is if there's a collection that implements the concept of iteration, and I want to get each element of that collection, I basically create a new iterator, and then I say to the iterator, you give me each element of the collection, I'm going to do some stuff, and then I'll ask you if there's any more elements, right? So while it.hasNext, it.getNext, it.do a bunch of stuff. In Ruby, it's actually much more concise. Like the previous slide said, you turn it inside out and you say, here's a piece of code, and here's a collection. Just apply the piece of code to the collection, and you manage the iteration, right? I don't care how map pulls things out of the collection, and I don't want to ask map whether it has next or has any more to do. You deal with that, right? That should be the concern of the data structure, because every data structure has a better idea of how to traverse itself. So let us see what an example of this might look like. OK, we're going to walk through this example together. Let me make the text a little larger. Hope everybody can see that OK. OK, so here is a simple example of the use of yield that yields a sequence of random numbers, right? And I get to specify limit, which is what's the range of the random numbers, like from 0 to 10, and num, which is how long that sequence should be. So what's going on here? I have a new class called random sequence. When I create a new instance of the class, all I do is remember what the limit and the upper bound are. This is the interesting part, right? My class implements each. So you can call each on my class just like you could do on an array and ask for each element. Now, how does that actually work? Well, OK, times, we've seen this before, right? It means some number of times do this. And this is the good part. OK? Rand times limit just gives you a random number that's within the correct range that you asked for, and floor truncates it to an integer. So don't worry too much about that part. The yield is the really cool part. Because now, let's actually pull this into a Ruby interpreter, and we can. OK, yield. This is one of my favorite things in Ruby. It's also one of the most confusing to understand. So this might take a little bit, but that's cool. OK, so now suppose we create an object of this class. Ooh, I got a bunch of random numbers. OK, but of course that's not the impressive part, right? The impressive part was each worked just like it works on collections. One at a time, it yielded elements back to me, and then I could do whatever I wanted inside of my do and end block. Right? So what's going on here in terms of the code is that when I call each, a bunch of code run, yield. As soon as the yield gets hit, whatever the argument of yield is, control goes back to the code that I wrote. OK, so as soon as I call each, here's a block. The very first time I hit yield, the thing that is yielded is going to be, I'm going to be thrown back into this do block, which is do with elt. And the do block does whatever it's going to do. And when it hits the end of the do block, I'm going to come right back up to the each. Right? So they're like coroutines. They're tossing control back and forth. This is a very weird concept to get used to if you haven't seen it before. And I'm going to convince you over the next few minutes of why it's a very useful concept for code reuse. So that was kind of a trivial use of yield, but here's a much niftier use that I think starts to hint at what you can do with it. A very common idiom is there's some kind of boilerplate things that I have to do before I do some work. Then I'm going to do my work. And then there's some boilerplate things that I have to do after my work is completed. So in most languages that deal with libraries, assuming that the before and after parts were pretty standard, the library might say there's like a before procedure and there's an after procedure. So what you're supposed to do in your code is you're supposed to call the before procedure, then do whatever you're supposed to do, and then call the after procedure. So that means that the library has to expose two calls, right? Before stuff and after stuff. Which, when you think about it, doesn't make a lot of sense, because if the before stuff and the after stuff are all boilerplate, that's one logical thing to be exposed. However, you could also, in Ruby, do this. You could define a single method around stuff, which has all the before stuff, yields, and has all the after stuff. So what's going to happen when this method is called? So in my doEverything method, I'm going to call around stuff with a do block. So as soon as I call around stuff, what happens? Control goes into the around stuff procedure, before code, running, 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 yield, bang. As soon as I hit the yield, control comes back to me. Now in this case, yield doesn't have an argument because my do block doesn't have an argument. Right? In this particular case, there's nothing to pass. There's no value to be yielded. I'm just yielding control. So yield, control comes back, my do block starts executing. I do all of my custom stuff, which could be arbitrarily long. And as soon as I hit end, control goes back to the point just after the yield, and now the after code can run. Okay? So, by the way, in both examples, this one and the one that I was struggling with pastebin, both cases involved transferring control back and forth, right? The only difference is that in the pastebin example, because the control transfer, if you remember, whoops, there we go. The control transfer, if you remember from pastebin, is inside of this loop, right? num.times. So why is it that I'm getting each element of the collection? Well, it's because I have a loop that says go through that many elements. So this is going to yield that many times, and as many times as it yields, control will ping pong back and forth. Whereas in my example of the around stuff, there is no loop involved. Whoops. There's no loop involved, and there's only one transfer of control. But you can see why this is a much cleaner way of wrapping up the sort of template functionality that goes around your code. And in fact, when we talk about views in Rails, this is exactly how views work. Right? There's a bunch of boilerplate stuff that Rails has to do just to get ready to generate HTML. Then it's time to generate the HTML, but that's what your app does, right? You have markup and HAML that you want to generate, and all that happens is it yields to you. And when your code is finished, you yield back to the view renderer, and it finishes doing all the boilerplate and sends the result back off to the presentation tier. Blocks are closures. Again, most languages have closures, but they don't allow them to use them very efficiently. What's a closure? It's the set of everything that you can see at a given point in the code or at a given point in time. And if you took 61A with Scheme, it was called an environment in that class, but it's the same concept. So the important thing here is, although it's almost second nature when you see the blocks, it's good to realize that blocks are closures. They carry their environment wherever they go. So what does this mean? Let's, hopefully this one will be a little more seamless. Here we go. So, going back to my simple random sequence example, suppose that I called it in the following way. I'll take my random sequence, I'll examine each element of it, and if it's less than any element I've seen so far, I'll remember it. Now, of course, this is very un-Ruby-like, right? In real life, we would just call min, which is defined in enumerable, but don't worry about that fact. For the purposes of example, here's what I want you to realize. Remember that I said as soon as we call each, control goes up to this each function. The each executes, executes, executes. We hit yield. When yield comes, I'm now back in my block, right? So the question is, at the point where yield transfers control back to me, what is the lexical scope of the program? What is the set of variables that it can see? And the convenient answer from the programmer's point of view is the variables that it can see are exactly the ones that existed at this textual point in the program. Right? So, to be more precise, this piece of code in here, inside my loop, cannot see any of the variables that are defined up here. They're separate scopes. So not only does yield transfer control back to you, it puts you back in the scope that was in force at the time that you provided your block, your do end block, to call whatever function it is that has the yield in it. Right? So what does this mean in practice? And again, when we do how Rails works, sort of under the hood, we're going to see some examples. The way blocks help reuse is they let you separate what to do from where and when to do it. At the moment you define a block, all of the scope that's visible, including variables that came from outside that block scope, all of that is going to be frozen in time, and whenever that block gets called as part of a yield, all those values will still be available, even if it gets called infinitely later. Right? And in fact, one of the things we'll see in Rails is that there are methods where you could say, here's a block of code that validates whether a given object meets a certain set of constraints. And that might require accessing a lot of state in and around that object's definition, even though the block is going to be used much, much later when the user tries to create a new object. All that state that was available when you define the block is carried around by the block anywhere that it goes. So this is a really, really cool thing, and we'll see various examples of it in Rails. So we've seen that duck typing is a different way to reuse behaviors. As opposed to inheritance, you can mix in things that make usually some assumptions about what your class does that's being mixed into. And it uses this method called modules, and the everything is a message language semantics really help with this. We talked about blocks and iterators. For those of you who come from languages that support lambda expressions, blocks are anonymous lambdas. They're closures in that they carry their environment around with them, so you can use them in all different places, and all of the variables the block tries to refer to, as long as they were available in the place where the block is defined, it's guaranteed that they'll be available when the block is executed later someplace else. And the net support of this is that you're sending code to where the objects are, right? Instead of asking for an iterator from a collection, you are allowing the collection, for example, to manage its own iteration or its own traversal, saying, here's a piece of code, it's your business how to do the iteration. In fact, one of the nice things we'll see, a way that this is implemented in Rails, is that when you iterate over lines from a database, you don't actually do the line fetch until the very last minute. So you say, give me back a bunch of database records matching this expression, and you get something back, and you might think, because of the fact that you can call each and do all this other stuff on the result, you might think that the result is a collection, but it's actually not. It's an object that quacks like a collection in that as soon as you try to dereference it, then some action happens in the database. And the fact that those two things are separable in time means that you can do some very neat tricks with caching and other stuff, all of which we'll talk about in due time.